So welcome students. So in the series of sessions of projection of lines, today we will solve one more problem, obviously by the concept of bearing. So you need to practice more problems, then only you will get to understand exactly how to deal with the bearing types of problems. Some of the statements already we concluded, that front view and top view lies over the same projection. AF and BF, that is other point of the line, BF and capital B. Capital B is notation for AF, AB is notation for your regular true length, whereas BF and BH, these are the notations we will use for front view and top views. And if you know locus of point B, then over this locus, same locus BF and point B lies. Similarly, if you know locus of point B in case of top view, over the same locus BH and other point B lies. Gradient is the term which we used in order to show the slope of a line, and gradient is a true inclination of a line, that is similar to theta, whereas bearing is a top view inclination of a line, that is nothing but beta. So theta and phi are the true inclinations made by the line with respect to HP and VP respectively. Now in today's session we will solve one more problem where front view length 55 is given, top view length 45 mm given, and bearing N40E, that is north to east 40 degree with respect to point A is given. So how to deal with this problem? We will solve step by step. Okay. So first of all, we will take any point above XY line somewhere here, and we will draw a 55 mm line. Yes, we cannot draw 55 mm line because we don't know front view inclination. So let us take top view 45 mm and its inclination is also given N40E. So this particular convention, just I will move at this particular point, yes. Okay. So let us one more above, it is far beyond, yes. Okay. So what is the top view length 45 and its inclination is, bearing is a top view inclination, N40E means from north to east 40 degree. In order to do that, I will take dummy lines because in AutoCAD that is not possible. Okay. So north to east 40 degree. So from north to east 40 degree. What is the inclination? North to east 40 degree. Remember, north to east 40 means from north to east we need to draw, and that is 40 degree. Now this inclination is showing east to north. So what we will do? So here you can see, if you draw this line, let us assume somewhere from this point, it's showing inclination from east to north 38, 26 like that, but we need to draw it from north to east 40. Obviously north east angle is 90 degree. From north to east 40 means east to north 50 degree. Okay, because 40 minus 90, it is comes 50. And what is the length? What is the length we need to draw? What is the length we need to draw? That is top view length 45. So this line I will repeat once again. So east to north, what is the length? First of all 45, and what is the angle? 40 degree. No, sorry, 50 degree. Okay, over. So this is our line, and this line is a top view line because it's apparent inclination. You can measure the angle if you want. Yes. Okay. So north to east 40 degree. So let us rename these points as AF. So I will move this AH. I will copy the same points. Yes, and one more point here. So this is my point AH, and this point is my BH. Or so front view part over, very simple, front view part over. Now let us extend the projection line from point AH as well as from point BH. So projection line should be very thin. Now front view length 55 mm given, so we don't know front view, so let us draw our locus of point A. So this is my locus of point A. Where is that line? Yes, so this is my locus of point A. So front view length is 55. So this is my point AF. I will move this point to here. Okay. Now this intersection is my point AF. And what is the length given? Front view length. So front view length is 55 mm. So what I will do, from this intersection point AF, you take compass, and radius in your compass is 55 mm. We know that front view and top view lies over the same projection, means over this BH projection BF point lies, but we don't know its locus, but we know front view length. So you take compass, radius in your compass is 55 mm, AF as center, and you draw one arc over this vertical projector coming out from point BH somewhere here. So I cannot draw arc, but I can draw circle. So my center point is AF, and what is the radius? That is 55. So it's cut somewhere here at this point. So I will copy these same notations, and this is my point BF. This is my point BF. Now I will delete the circle. Oh no, I cannot delete circle. I will draw a line. Now I have obtained locus in case of front view. You draw a line, obviously red in color, and join AF BF. So AF BF is your front view. Okay, so means both the views now you have drawn. You can show the dimensions if you want. So this is the dimension, this is the length, 55 mm. Yes, correct, exactly 55 mm we have drawn it. Now we need to find out what? True length. So how to find out? If you rotate front view up to the locus of point AF, then you can vertically extend it down projection. You will get true length in case of top view. If you rotate top view, you will get true length in case of front view. Okay, so what we will do? We will rotate front view. Let us rotate front view. So how to rotate it? We know that you can draw an arc. This is my starting point, this is my center point, so you can draw an arc. Better I will draw a circle because that is simple to me. And this is my center point, this is radius. Okay, up to this point, this is the locus of point A. So up to this locus, so this circle is cut at this particular point here. Yes, you can see AF, locus of point A. Now from this point I will draw vertical projections down up to locus of point B in case of top view. Okay, so projections down up to locus of point B. Obviously this has to be perpendicular line. Okay, so I have rotated AF BF, I have rotated AF BF up to this point. Yes, I have rotated it. Then vertical projection down up to locus of point B. Now I have locus of point A in case of top view. So from point AH I will draw a line up to this point, and this is my true length. Okay, so I will copy the same dimensions, same number. In fact, I will remove the H. So this is my point B and this is the true length. You can measure the true length if you want, and also you can find out angle phi, because phi is a true inclination made by the line in case of top view or with respect to vertical plane. So AHB is the true length. Similarly, you can draw true length in case of front view. How to do that? Very simple. You rotate BH, that is front top view, up to locus of point A, then from this projection you can draw it up. So just I will show you. If you want, I will extend this line. Okay, now rotate this. So I will rotate this. Better I will draw circle because that is simple. Center point, and this is the radius. Yes. Then from this intersection point I will draw a line up to locus of point B in case of front view. I will delete the circle. Then you join AF with respect to this point. Obviously this is a white in color. This has not connected correctly. Yes. Yes. Okay. So by using this way you can easily find out true length in both the views. It has not come correctly. I will draw once again. Yes, this is the point. Next point, what is it? Okay. So by using this way you can easily find out true length. If you know front view, you rotate front view, you will get true length in case of top view. If you know top view, you rotate top view, you will get true length in case of front view. That is the simple way. So you can measure the true length if you want. This is the 65.33. Okay, you can measure theta, then you can measure phi angle. So that is the problem for you. You just complete it.